I'm David Rives, host of Wonders Without Number. In each episode, we talk about breaking discoveries in science, which reveal that our Creator, the God of the Bible, has left a pattern of His fingerprints throughout the universe. Check out our other resources at davidrives.com. Sign up for email updates to have encouraging nuggets sent straight to your inbox. Subscribe to our free monthly magazine and like us on Facebook for daily inspiration and education regarding science and the Bible. Charles Darwin's original ideas of evolution were proposed at a time when virtually nothing was known of genetics or inheritance. But what do we know now, and how does that fit with biblical truth? Find out on Wonders Without Number. Welcome to Wonders Without Number. I'm David Rives, and today we want to inform and inspire you regarding the wonders we find all around us. An infinite number of wonders that point us directly to our Creator, the God of the Bible. Now, you're no accident. I want you to know that you are special, that you were created in God's own image, that Jesus Christ was and is that Creator, and that He has a plan for your life. Now, in biology classes across the nation, students are reading in their textbooks that one kind of animal has turned into another kind, and that it's happened many times in the past. But what about adaptation? Well, let's take a look right now. Why should you believe in creation and not evolution? I mean, scientifically speaking. Haven't we proven that evolution is a fact? Okay, so here's the thing. Let's define evolution, because if you're talking about microadaptation, or birds with long beaks versus short beaks, that one's an easy yes. Animals within a group, let's say loosely the canine family, can adapt to their surroundings because of extra information in their genetic sequence. So how does this work? Basically, you take a dog, let's say he's got nice long hair, and you breed him with another. Let's say that she's got really short hair. Well, with the genes from both parent dogs and the offspring, you could come out with a long-haired puppy, one with short hair, or anything in between. You see, the genetic variety is there. But as you do more selective breeding, say only using short-haired dogs, then pretty soon the genetic information for long hair is going to be weeded out, sort of switched off. That's what happens. It's observable, and we've done it tens of thousands of times. But think about what's happened. The more time that passes, the dogs are either losing information or more genes are being switched off. For upwards evolution, we need a continual increase of information over time. Not only do we not see that happening, but it's not going to magically start happening even if you give it millions of years. And the other thing to remember is there seems to be definite boundaries within the animal kingdom. You know, the old jokes we used to tell, like, what would you get if you cross a giraffe with a rooster? Well, I mean, it's funny, but that doesn't happen in nature. One kind of animal never just changes into another. It's also really funny because that's what Darwinian evolution entails. They tell us, just give it enough time. But they're not joking. So maybe adaptation is better explained from a creation standpoint. A creator, designing specific kinds of animals complete with a diverse genetic code capable of self-adjusting. But what about mutations? We'll touch on that some other time. And you'll see that there are major problems with that as well from an evolutionary standpoint. Just one more scientific reason that you shouldn't believe in molecules to man evolution. It takes a lot of faith. I'm David Rives. Truly, the heavens declare the glory of God. Small observable changes within an animal family is normal. But a study of genetics shows us that there are major problems when we try to turn an amoeba into a man. And that's one of the topics my guest is here to tackle. Now, Dr. Kevin Anderson received his PhD in microbiology. He taught graduate level molecular biology and cell biology, and he's published numerous articles in technical journals. He's also the co-director of the Creation Research Society's eKinds project. Now, that's a project investigating mechanisms for rapid speciation and diversification within a biblical creation model. So if you would, please join with me as we welcome Dr. Kevin Anderson. Welcome to the program.
It's my pleasure. Thank you.
It is wonderful to have you here. Now, you are based out of Arizona, is
Correct,
that right?
yes.
Okay. Tell me a little bit about CRS.
The Creation Research Society was founded over 50 years ago, 1963,
Wow.
as the creation science organization of scientists who are also Christians and creationists.
Okay.
And our function is to provide scientific evidence, to provide a scientific model that fits with the biblical account of creation. Doesn't try to change it, doesn't try to adjust it, it actually conforms to it.
And that's exciting,
yes.
because with genetics and some of these other fields, your job has gotten even easier.
Oh, no doubt, as we're going to see here in just a second. What we're finding in genetics actually fits exactly what we would expect in a creation model that God created. He created organisms, ducks as ducks and cows as cows and trees as trees. That's what we're going to find. Yes.
That is so neat. Okay, well, I know that we've got so much information to cover, and I want to give you as much time as possible, so I'm going to let you take over from here.
All right. Well, the first thing we have to understand is that evolution has to be more than just mere change.
Yeah.
So much of the time in our classes and even in the scientific literature, evolution is just simply defined as change.
Okay.
But there's no explanation of what kind of change, how long the change occurs, and to me that becomes meaningless. Then it doesn't explain anything, it doesn't predict anything, therefore scientifically it's useless.
Okay.
All right, so what evolutionists are actually saying when they're talking about change over time is they're referring to universal common descent. The idea that all life has come from a common ancestry.
Okay.
That at some point in time, we share a common ancestor with cows and with frogs and with fish, with trees, with rose bushes. See, so all life essentially comes back to a commonality, a common point. That's what they're really talking about, and that's what actually distinguishes creation from evolution.
Okay.
We believe in change, we just believe in a different kind of change than they talk about. We reject this universal common descent. We reject that we share a common ancestry with other life.
Okay.
So Richard Dawkins made a correct statement that he said that the fossil record provides circumstantial evidence for evolution. So in other words, if you have a certain theory, you're going to be able to interpret the fossil record based on that theory.
Okay.
Right? That's like what we would do at a crime scene. You take the circumstantial evidence, the fingerprint, the footprint, the ballistics, the witness testimony, the indirect testimony of the witness who saw the person running across the street, something like that. And all that provides a circumstantial case. You then need what I would say a viable theory to make that circumstantial evidence fit, to make it, to be able to interpret it.
Okay.
Okay, so what we have is the evolutionists have taken, and their theory is that mutation drives these dramatic changes. Therefore, the fossil record shows these dramatic changes over time by their interpretation.
Okay.
All right. Yes.
Okay.
So that becomes the circumstantial evidence for evolution through the fossil record. But see, it starts with genetic changes. It starts with something that alters that genetic information in the cell. Because you're not going to go from a single cell to a human, a single cell to a dinosaur, a single cell to an oak tree, without dramatically modifying and transforming that genetic information that's in that single cell.
So to try to get universal common descent, you start with a basic creature, but somehow you have to change the information in the genetic sequence of the creature.
Correct.
Okay.
Dramatically.
Okay.
Dramatically you have to change it. Yes. And therein lies where I would say is the true weakness of their theory, therefore they're applying a wrong interpretation to the fossil record. Okay, so what we have is, see, with DNA, it's a double-stranded molecule that contains then the sequence, the T, the C, the G, the A, and we see the illustration here that
here.
like letters on a page.
Okay.
Okay, that provides an informational content. Okay, you change then the lettering, just even here, we change the C to a T.
Okay.
Or a G to an A. Now, like you've changed a letter in a word, you've potentially changed that word to a different word, but more likely you've changed that word to not a word at all. Right, exactly.
Wouldn't be recognizable.
And so that fits also with DNA.
Okay.
So evolutionists are pointing to some kind of changes occurred, either small or big, depending, but changes have occurred to the DNA to change this sequence, which changes then the informational content of the DNA, just as like changing letters on the page, change the informational content of that page.
Okay.
So what we have then is their theory that they're applying to the fossil record says that mutations, changes to the DNA, have given us this universal common descent, that's allowed this very simple single cellular form to become a fish, to become an oak tree, to become a human.
So it changes in the genetic sequence.
Exactly. You have to
change it enough times, and maybe we can turn something like this. Okay.
Yeah. Either small changes, big changes, but over time, the accumulation of these changes is what they're looking at.
Yes.
That's driving the universal common descent.
Okay. What do we actually, as a professional in the field, you've studied these things.
Yes.
What are we finding?
Yes. All right. Here's what we actually find. Now, this is what I'm calling the simplistic mutation proportion, simplistic mutation model, where half of your mutations are bad, they have negative effect, and half of them are good. They make you X-Men, they make you better, stronger, faster.
Okay.
I call that simplistic because that's not really how it is. See, from this, they say, well, the good genes stay and bad genes go. See, natural selection comes in and says, okay, you're slower now, so you die off. You're weaker now, so you die off. And when you die off, you take your bad genes with you. See, you're stronger now, so you survive. You're faster now, so you survive, so you keep your good genes. So this is that very simplistic, bad genes go, good genes stay. Okay, that's nonsense. That's not how it works.
Okay.
All right, here is a much more realistic illustration of the proportion of how where mutations fall. All right, notice that virtually all the mutations are on the bad side.
Yeah, I see that in the negative.
Virtually all of them are on the bad side. In fact, when we look on the good side, when we look on the good side, what we in fact see is this is enhanced even. It's so small we wouldn't even be able to see it actually on a graph. So we have to make it bigger than it actually is so that you can visually see it. We're not saying that there isn't a mutation that doesn't fall over in that category. We're saying that they're very, very few and far between.
Okay.
Most fall in the other category. Now, what I've marked in red are those that are going to be so negative that most of the time, it's probably going to kill the organism.
Okay.
All right. But those in the gray are what are called a non-selection zone. In other words, they have very, very little, if any, noticeable impact on the creature.
So the majority of the mutations we find are on the negative scale.
Correct.
But the majority of those negative mutations are not drastic.
Correct.
It's not life-threatening.
Yeah.
Okay.
If it slows you down by 30 thousandths of a second, okay, that may affect you if you're an Olympic runner,
right?
But it's not really going to affect you if you are a lion out hunting.
Okay.
So natural selection can't see that. That's not going to have that kind of impact. So they're what we call non-selective, but those do accumulate. They don't just disappear, they accumulate. And when they accumulate enough, see, then John Sanford wrote a very good book called Genetic Entropy on this, where we see when they accumulate enough, they then do start impacting have a negative impact because they just simply build up. You can't introduce errors over and over again and not have it begin to affect your book, have it affect your DVD.
Right.
Those eventually distort the content on there. So that's what we see with these kind of mutations.
Okay.
Okay, but let's talk for just a second about the difference of what we mean when we're talking about the effect it has versus the mutation itself.
Okay.
And then explain how those good mutations aren't really quite what evolutionists are saying they are.
Hi, I'm David Rives, host of Wonders Without Number. Like what you're seeing? You can find so much more on the Creation Superstore. You'll find over 1,000 books, DVDs, and other quality resources on origin science, creation and Bible history. Whether you're looking for nature documentaries, educational books, homeschool resources, or children's videos, we've got it all, so be sure to head over and check it out. Use this special promo code to receive 10% off your first order.
There's a difference between what we call phenotype and genotype. Phenotype are the physical characteristics, your eye color, your hair color, the shape of your build, your height. Those are all your phenotype. A lot of that is genetic. You know, you couldn't control your hair color.
Right.
Okay, that's your parents' fault. Yeah,
right.
Be it good or bad. Okay. You couldn't control your eye color. That's your parents. So you inherit those.
Okay.
So that's your phenotype. Now your genotype is the actual genetics. Why do you have your hair color? Why do you have your eye color? Why are you as tall as you are? You know, why do you have certain colored skin, not other colored skin? Those are the genotype. So when we're talking about mutations, we're talking about changing the genetic content, we're looking at the genotype, but we're often measuring it in terms of how it affects the phenotype. See, if we go back to this slide for just a second, see, this is all based on phenotype.
Okay.
You know, is it making you slower or faster, making you stronger or weaker? That's your phenotype. But what is occurring to cause that, that's the genotype. I challenge that all too often evolutionists have talked only in terms of phenotype and not in terms of genotype. And therein lies, I think, the problem.
So you have to get down to the root of it.
Exactly, because beneficial mutations, which clearly do occur, we're going to give some examples. Beneficial mutations, mutations that do provide at least a temporary benefit, are usually identified by how they affect the phenotype. But typically there's only minor regard, if any, of what's actually going on at the genotype level. And this is what we've got to look at. All right, so let's use, for example, you're familiar with malaria.
Yes.
Okay. We don't have malaria around here, fortunately, but there are portions of the world where malaria is fairly common. Now, you've probably heard of sickle cell anemia. And that's considered by some evolutionists to be beneficial because it provides a protection against malaria. Which I find a little amusing. Is okay, what are you going to die of? Sickle cell anemia or malaria? You know, so I don't find that even from their paradigm very useful. I'm going to give them a better one. And it's called the Duffy protein. This is a protein that's on the surface of your red blood cells. And what has been found is if you lack that protein, you actually have a dramatic increase in resistance to malaria, and there's no known negative effect. Now there might be, we just haven't identified it because the negative effect seems to be very minor.
Okay, so when Berkeley, their top example of beneficial mutation is sickle cell anemia.
Which, if you think about it, that's ridiculous.
It really is. It's a very, very serious condition. But because of that condition, you may not die of malaria. Okay, but you're saying that
this is far better.
This is a better example.
So Berkeley, here's a much better one. Use this one. Use this one. But here's the problem. How is it that you're actually resistant to malaria? You're resistant to malaria because, you see, that Duffy protein seems to be where the malaria protozoa attaches to infect. If you don't have it, see, it doesn't affect.
It cannot connect.
But here's what happened. See, you were able to become resistant because you inactivated the gene making that protein.
That's not an increase of information.
Well, think about it. What you're doing is you're taking a pre-existing genetic activity, making a protein, and you're getting rid of that. How's that going to drive fish becoming reptiles? How's that going to drive dinosaurs becoming birds? How's that going to drive primates becoming humans? It doesn't. It's the exact opposite. You're taking pre-existing system and getting rid of it. See, when you look at the genotype, it's the opposite. Beneficial, yes, but it's the opposite. Let's go on. Another example, HIV. That is the virus that causes AIDS. Okay, there are some, and it attaches to a protein called the CCR5 protein. This is on one of your immune cells called the T cell. The CCR5 protein is where the HIV binds. All right, now, there are some humans that are naturally resistant to HIV because they have a mutation where they no longer express that protein. So they're resistant. Now, if you're exposed to HIV, that's clearly a beneficial mutation. But again, the genotype you've knocked out a pre-existing genetic activity.
Okay.
The pre-existing gene that's making that CCR5 protein.
So this is not a great example for evolution because it's like you're already starting with a book worth of information.
Exactly.
And you just happen
and you're ripping pages
rip
out.
a page out.
And it may be that under a certain circumstance, removing that page
Makes
is beneficial.
your job easier, yes.
Right. But that doesn't explain how that
wrote
page
the
got
book?
there.
Yeah.
Exactly. Here we go, lactose tolerance.
Okay.
All right. Humans, naturally, they're wild type, their original state, what Adam and Eve were.
Yes.
Okay. You could, when you're a child, drink lactose-containing products. Lactose is the milk sugar.
Okay.
And you made an enzyme called lactase in your digestive system that allowed you to digest that sugar. But as you move through puberty, there is a gene called the MCM6 that makes a blocking protein that now shuts that gene off. So you become what we call lactose intolerant. That's actually the natural state of humans. Adam and Eve would have been lactose intolerant because they wouldn't have needed to drink milk anyway. All right. So that's the natural state. But in those of us with a certain Northern European ancestry, we've had a mutation that's been introduced that knocked out this regulating protein, so it no longer blocks the lactase gene, so we still make lactase. So even as adults, we can drink milk.
Yes.
And I'm kind of glad I have that. To me, it's beneficial because I like milk, I like ice cream.
I like ice cream.
Yeah, so I'm kind of glad I have that mutation.
Okay.
But again, look at how it occurred at the expense of a pre-existing regulatory control.
Yes.
It doesn't explain where that regulatory control came from, it explains how you got rid of it.
Okay.
Okay, let's do antibiotic resistance. Very common one. Oh, antibiotic resistance proves evolution. Doesn't prove anything of the kind. It proves change. You have a group of bacteria. You expose them to an antibiotic, and a few of them survive.
Okay.
Well, what happened? Well, it depends on the antibiotic, but if we look at it, the resistance is loss of enzyme activity, halting cell division, loss of regulatory protein, loss of an affinity for gyrase, reduced formation of a transport protein, loss of affinity for RNA polymerase, loss of proton motive force. So it's lost, reduced, lost, reduced. So what are we seeing at the genotype level? We're getting rid of pre-existing systems. And that's how bacteria survive antibiotic resistance. Now, the beauty of bacteria versus us is they can get rid of something and grow it back. You know, they can literally chop their hand off and grow it back. We can't do that. So we're not near as versatile as they are.
Yeah.
See, so they survive by getting rid of something. When the antibiotic is gone, then they grow it back, if you will. They start making again and they survive. So very beneficial, but at the exact opposite of what evolution needs to drive universal common descent.
There are beneficial mutations.
Yes.
But
they're rare.
They're rare, number one. And number two, they do not provide the mechanism that evolution needs.
Correct.
Okay.
Let's use what I call my house analogy. All right. Let's say you in your house, you have a nice dining room area, and right by it with an adjoining wall, interior wall, is your rec room.
Okay.
But your wife, she decides that she needs a bigger area to entertain guests.
Okay.
So you look around your house and decide the only way to do that is you're gonna have to knock out this interior wall separating your rec room from the dining room. So now she gets this bigger room to entertain guests, which makes her happy. And of course, everybody knows if she's happy, everybody's happy. So it's beneficial. But how'd you do it? You knocked out a pre-existing wall and you lost your rec room. Do not tell a carpenter the house was built by knocking out a pre-existing wall.
Right.
See, that would make no sense, but that's what evolutionists are telling us all the time. Look, we knocked this wall out. This is how the house was built.
Yes.
No, it may be beneficial in a very temporary condition, but that's not how you built that cell, by knocking out regulatory systems, knocking out genes, knocking out transport systems. That's not how the cell is built.
Okay.
So my challenge is that evolutionists are applying the wrong working theory to the fossil record.
Yes.
Therefore, they're misinterpreting it, just as you would in a crime scene. If you apply the wrong theory, what happens? You come up with the wrong suspect.
Okay.
See, it would be like I take all the circumstantial evidence, the fingerprints, the footprint, the ballistics, testimony from the neighbors talking about how, these two men hated each other.
Right.
And so I issued an arrest warrant for the business partner that he murdered his, friend, or murdered his business partner, and then I find out he died 3 days before the murder occurred. I have to recognize I've been working with a totally wrong theory and therefore applying complete misinterpretation to the data, and I get the wrong suspect.
Okay.
And I challenge, that's what evolution has done. They've been working with the wrong theory, therefore they get the wrong suspect.
So, from a biblical perspective,
Yes.
give us the scenario. People, animals, all created things in the beginning.
Correct. Fully formed.
Okay.
That's very important. Fully formed. All our genetic information to be a human was already in place.
Okay.
All the genetic information to be an oak tree was already in place. Oak tree didn't evolve from a rose bush. Oak tree didn't evolve from some kind of coral in the sea, that crawled up on the land and became an oak tree. Okay, so fully formed, full genetic information. Now, mutations occur, alterations in DNA occur, so you have variations that occur, but that doesn't change oak tree into something else. God said to reproduce after your kind. Bears are still bears. We have a lot of variety of bears.
Okay.
Because God, with that programming he gave, allowed them to fill the earth. To fill the earth, we got to be able to adapt to all the different conditions. So you've got polar bears, you've got grizzly bears, you've got Kodak bears, you've got black bears, you got panda bears.
Yes.
Okay. I'm not even sure if panda bear's a bear actually anymore. I think they've changed it. But what we see in all of that is that diversity allows those kind of changes, but the bear still becomes a bear. The bear's still a bear. It's remained a bear. The fox has remained a fox. The humans remained a human. See, so we've not seen any genetic evidence, any genetic mechanism that allows the transformation where a bear is no longer a bear, where a tree is no longer a tree, where a human is no longer a human.
Right. And to start with something simple like this, which clearly did not have...
Which is also not so simple.
Exactly.
Yeah.
It's not so simple with compound eyes and everything.
Yeah.
But to start with something like that, it clearly does not have the genetic information
Correct.
to produce all of these other things that we've seen.
That does not have the same genetic content as an oak tree.
Okay.
Therefore, it can't just suddenly tomorrow be an oak tree.
You would need an increase or an addition of information, and what you've looked at today are all of these deletions of...
I wouldn't even call it necessarily an increase of information because that's hard to define. I would just simply say you need a total transformation of the information.
Okay.
And that is where the evolutionist community has failed to provide sufficient evidence to support their theory, is how do you provide sufficient transformation of the information to go from that to an oak tree, to go from that to a dinosaur, or to a bird, or to a human.
Wow, that's so exciting. Now, you've written a book called The Who of Creation. And you answer a number of different questions in here, and I would encourage people to check that out. The Who of Creation Answered by Kevin Anderson. Thank you, Kevin, so much for being here today, and we're going to have you back on a future program.
My pleasure.
All right.
Thank you.
Yes, sir. Genetics has changed, and we've learned a lot over the past 150 years. But you see, what we've learned is that Charles Darwin didn't even have a clue. He was calling for mechanisms that just don't work. And now that we know that, why do we still hold to the failing theories of evolution? We're not random mutations. We are fearfully and wonderfully made. But on top of that, our Creator wants a personal, eternal relationship with each one of us. And He's provided a way through the shed blood of our Savior, Jesus Christ. In Him, we live and move and have our being. And we hope that you've been encouraged and educated today, and we want to give you the tools that you need to boldly go forward and share what you've learned. So leave us questions and comments on our Facebook page and give us a call to learn more. I'm David Rives, and until our next time, keep looking up. Truly, the heavens declare the glory of God. Hello, I'm David Rives, host of the TV show Creation in the 21st Century on TBN and the Heavens Declare video series. Each week we talk about breaking discoveries in science which reveal that our Creator, the God of the Bible, has left a pattern of His fingerprints throughout the universe. Engage with other like-minded believers through the Creation Club. This website offers thousands of articles written by scores of authors in multiple languages. Sign up to get our free monthly magazine delivered to your door. Want more? Genesis Science Network is our free 24/7 TV network, reaching millions of people around the world on internet, Roku, Fire TV, and mobile devices. Shop over 1,000 books and videos on the Creation Superstore, the world's largest Origins-related store. Visit our Wonders of Creation Center and sign up for email updates to have encouraging articles sent straight to your inbox. Like us on Facebook for daily inspiration and education regarding science and the Bible.